here. In contrast, other heavy metals added at this same concentration, such as aluminum, lead, cadmium, and manganese, did not produce this effect. To understand how mercury causes this degeneration, let us return to our illustration. As mentioned before, tubulin proteins link together during normal cell growth to form the microtubules which support the neurite structure. When mercury ions are introduced into the culture medium, they infiltrate the cell and bind themselves to newly synthesized tubulin molecules. More specifically, the mercury ions attach themselves to the binding site reserved for guanosine triphosphate, or GTP, on the beta subunit of the affected tubulin molecules. Since bound GTP normally provides the energy which allows tubulin molecules to attach to one another, mercury ions bound to these sites prevent tubulin proteins from linking together. Consequently, the neurite's microtubules begin to disassemble into free tubulin molecules, leaving the neurite stripped of its supporting structure. Ultimately, both the developing neurite and its growth cone collapse, and some denuded neurofibrils form aggregates or tangles, as depicted here. Shown here is a neurite growth cone stained specifically for tubulin and actin, before and after mercury exposure. Note that the mercury has caused disintegration of tubulin microtubule structure. These new findings reveal important visual evidence as to how mercury causes neurodegeneration. More importantly, this study provides the first direct evidence that low-level mercury exposure is indeed a precipitating factor that can initiate this neurodegenerative process within the brain.
The days when we could blindly trust our government and media are over. These corporations care about nothing other than the almighty dollar. Okay, corporations are legally bound.